let's get started. Okay, so today we have our last guest speaker. So he'll go first, and then after that we'll take a break, and then we will discuss two things after the break. One will be more about intellectual property. The other will be I've decided to give you a little more help on PS12. So I'm going to show you a partial implementation of the solution. So I think it's worth seeing. But we'll start with Chris Johnson here, who works for Cameo, which is a startup in Provo. He graduated 4 years ago, and he's going to tell you what it's like there.
Cool. All right. So 4 years is not a lot of time out of the U, but hopefully we'll be able to get you some things answered. I've got a few slides, but really this will go best if you have questions. I know you've had other guest lecturers. Anything that's on the table, we'll talk salary, we'll talk what it's like, we'll talk anything that you want to know, tools, Mac versus Windows, whatever you want to talk about, we can do that. So be thinking. 40 minutes is a long time without any questions. Really, really long time. So, I am not the famous Chris Johnson from the Ski Institute. I've been out for 4 years. So what am I going to tell you here? One, I'm going to tell you how lucky you are to be doing what you're doing. Give you a couple of survival tips. As I understand it, you're in your sophomore years, your third programming class. And hopefully this will have a couple of things that helped me and will help you survive the classes to come. And then we'll just go through questions. If you have any questions, what it's like to work for a startup, what it's like to work for a larger company, anything you want to know. So we'll just get started. Good news for all of you. Software engineers are in demand. You have picked a good career path. Everybody needs you. Everybody needs you. Music people need you. Salespeople need you. Everybody needs what you do. So you have picked a really good career. So kudos to you. And the good news is that even fresh out of college, you're going to be qualified for a job. I know it's not going to feel like that. I left the U thinking, who's going to pay me to do what I know how to do? It's okay. Deep breaths, you're going to know everything you need to know. There's a reason why you're going through different programming languages. What language are you doing now? C#, Java? C#. Okay. You might run into Java before it's done. You might run into Python. You might run into C++ somewhere along the line. All of those are things you're going to be able to put on your resume. If you spent a class doing that, you're cool. You're able to put that on a resume. People do not expect you to be masters fresh out of college. They expect you to know how to use the language, and they expect you to know how to learn and pick stuff up. So don't freak out about that. Another cool thing right now is you get some time to figure out what kind of software engineer you're going to be. To talk about that, yeah, let's talk first. How many of you want to be game designers? Yeah? Any mobile developers? People who want to do stuff for phones? Okay. Desktop? Testers. Anybody want to be a software tester? QA engineer? Hey, not many of those. Well, hey, you can break stuff and make life miserable for people. I've got a tester who's bugging me right now. But there is a lot to think about what those jobs really mean. Well, we'll get into that later, but you can decide. If you're a more artsy person, you can do front end. You can be a designer. How many of you kind of want to go into the design side? UI, user experience. Hey, we got a couple. That's a thing now. That's a thing that didn't used to happen a lot. You've got people like me who can't make a nice UI to save their lives. And that's why we've got designers. We use Zeppelin. They show me exactly what it should look like. They give me the pixel perfect, where it should be, and then I can make it. And it looks nice and everybody's happy. That's a thing you can do. Let's go on to stuff for survival. So how many of you go to office hours? Joe, how many people go to office hours?
For this class, for me, very few.
Okay.
I think the TAs are busy.
Okay, that helps. But I mean, office hours saved my life so many times. He's there for you. Your TAs are there for you. The CADE lab, you know, even when you're not fishing for TAs, even being in the CADE lab, being around people who know more than you, that's helpful. That's really, really helpful. You know, I talked to Peter Jensen about this, you know, talking about working with others even when you don't have to. I didn't like working with other people very much. But once I got to know some folks and we could work together, not sharing answers, but if you're banging your head against a semicolon and figuring out what's going on, a fresh set of eyes can really help you out. So you can really take advantage of being with other people. I mean, you're going to be working in teams throughout your life. Nobody's going to be working by themselves. That's, I mean, in college you're doing stuff by yourself now, right? You're doing your assignments on your own, maybe. I hope you're not. But figuring out that you can get help from other people. I mean, when you get your first job, right, you're going to be asking your coworkers for help, right? You're going to be asking your coworkers for help. So being able to work together and learn from those around you is going to be huge. And beyond that, just putting in the hours is going to help you out. Let's get going to another interesting thing. I mean, this is still going to balance. You're going to need to start working as a team. You're going to need to find people who are different than you. I know you've all heard the whole diversity thing, but it does make sense. If you want to have a good application, you're going to need a team. Nobody builds it all by themselves now. Right now, where I work, we've got a team of 3 designers, 3 guys that do nothing but design. They do nothing but put up nice and shiny designs for us to work on. We've got an Apple guy, iOS. We've got an Android man. And then we've got a couple of web developer guys. That's all, yeah.
Is it all guys at your company?
Unfortunately, yeah. And which is a real problem, actually.
We're not very diverse.
You're right. 2 of the guys are on the other side of the world, though. I got nothing for you, okay? And, you know, worst of all, it's a retail company where we're working for retail folks, you know. We're trying to help folks gather the data they need in a retail store. And with that data, we can start to predict what they need to do to make more money, which is really kind of cool and data heavy, and you can start to predict things. That's really cool and interesting. But to relate with the people who are working in retail, us guys aren't doing super well at that. We send guys in there and they just don't speak the lingo. You send them into, you know, a ladies' clothes shop and they just don't. It doesn't work. We've hired a gal that knows how to do that and knows how to talk and knows how to pitch that. And so as far as developers go, it's just guys. That's a problem. It's not good. But we get that's not ideal.
Are they all white guys?
No. We got a Japanese dude. I'm sorry. Alright, back to what kind of software engineer you want to be. You want to be thinking about that. What do you want to do? Are you going to be an iOS, Android? Are you going to do a little bit of everything? Are you going to do back end? Are you going to do gaming? You need to figure that out. You need to figure out what you like and what side of software engineering you want to be on. It's really easy right now to explore. You've got all sorts of electives that you can take right now. I know there are really cool electives that you can pick once you get through the first couple of classes. Yeah?
How important is the focus of like deciding when your educational career, but what sort of programming you should be focusing on?
It really, I don't think you can know all the way right now, but you can at least figure out what you like and what you don't like. You know, that's kind of where those electives go in. I mean, there's natural language processing here. There's machine learning. They have a really cool VR class. I took Peter's competitive programming class, and that was kind of cool. I understand he's not doing that anymore, but that was another really cool class. This is the time to explore. More than anything, you get to look around. There's just a lot to look at. You really should look at your electives and see what looks good. I really enjoyed machine learning. I really enjoyed NLP. Those are kind of nitty-gritty nitty-gritty sciencey ones. I did the data science class, and that was really cool too. Through that data science class, I actually ended up doing an undergraduate thesis at the Ski Institute, and that at least told me that I didn't want to do research, but that was something that I'd been thinking about before. I saw a hand. What was that?
How much are you touching right now?
Which part?
The ML or the NLP?
I'm not touching NLP very much. We have a small bit of NLP on our website for a cool little word cloud. You know, we do surveys and people answer, and you can do a little bit of NLP to figure out what phrases and what words are the most important. That's the extent that I'm doing NLP. Machine learning, on the other hand, and I'm not doing as much with it. I wish I were doing more, but knowing how it works gives me a lot of power to tell my startup bosses, say, yeah, no, machine learning doesn't do that. You know, you'll find a lot of people think that machine learning is a magic bullet, that it will save everything. It doesn't, but it can do some really cool and powerful things. So being able to know what it is and know whether or not you should use it, that's powerful and handy too. Anything else? Okay. Again, if you find yourself being an artsy person, there's all sorts of stuff there. If you find yourself being less artsy like me, there's stuff to do there. Database work. I took a big data class here. That was really cool. I really enjoyed doing that. That was handy for my first job out of the U was I went to work for an oil company, and we were doing lots and lots of Visual Basic SQL reporting, which was really, really not where I wanted to start. But the good news was that I had taken the big data class, and I knew what was going on with the queries that I was making. I knew how to write SQL, and that was all that really needed to happen. In that company, I was able to transfer over to be one of the C++ guys. I started as an intern there. They hired me full-time, and then I moved over to C++. That was how I got to my first real job. I saw the oil company here at their career fairs. I encourage you to go and find those. They've got them for you, and you can find people who are looking for interns. They love interns. I did my internship during my junior year. Junior year summer, I got a full-time internship, and I also did the internship class from James to Saint Germain. I don't know what it's exactly called now, but it was you got class credit for doing a full-time internship during the summer. That was really cool. It is not a get-out-of-free class, though. He's going to make you write. He's going to make you write a lot. He's going to make you interview people. You're going to interview different engineers, and then he will visit you at your place of employment. He will come and sit down in your cubicle and ask you what you do. He'll meet your boss, and he'll ask, how's the U doing preparing you? Did the U prepare you well enough to be a useful intern? But that was a really cool way to get paid and get some class credit and actually really examine a job. He'll ask you to write about if you like it there, what you're going to look for in your next job. That's a cool thing to do too. You can look into that and ask him about it. It was a cool experience. If you're also looking for another way to do it, you can do undergraduate research. UROP. You can actually get paid to do research. Find a professor that will let you do that. I found Mr. Rosen up in the Ski Institute, and he let me do some research. And that was another cool way to get class credit, learn whether or not I wanted to be I didn't know if I wanted to research, go into academia. But that told me that wasn't for me. So that was a cool way to do it. Yeah?
Did you have to get a sponsor when you were getting credit for your internship?
When you say sponsor?
From a professor. One of the requirements I looked over said that you had to go to a professor and get a sponsor.
That's where James de Saint Germain.
Okay.
I took it to him, and he looked at the job, he looked at it and said, yeah, you're good to go. So, yeah.
Were there any side projects that you did that really helped you get those interviews and land those jobs?
You know what? I didn't have many side projects. My research was really my big thing. I thought I had plenty to do with just the normal schoolwork. I made it through in 4 years, and that was a lot to do. but to having the research was something that I could talk about a lot. I don't think you need more experience than what your normal classes will give you to get an internship, but if you have a side project, think about what that tells your employer. That tells them that you enjoy coding, or that you've got plans to do something cool. It means it means you care. So if you have a side project that you like and that you can talk about, full speed ahead, put it on your resume. But when you get out of here, what do you think is going to be on your resume? Most of it's going to be your classwork, right? It's going to be your final project. It's going to be all the classes you took. As you get experience, that shift will gradually move towards outside work, but everybody expects that. That's normal, and that's okay. So, yeah.
Was there anything particularly about research that like turned you off to it, that kind of pushed you more in the direction of anything else?
I got really lonely.
Okay.
Which is funny because I'm working from home right now, also really lonely. But you know, I would sit down and I would have a, you know, the data that I was working from, it was a really cool uncertainty problem about the human torso. So to figure out how electricity goes through a human torso, you can't really test that well on people. What you can do is you can take little pieces of tissue, fat, muscle, heart, all that sort of stuff, and you can make a really fancy pants model for it. And since you're not exactly sure how it's going to work, you can run that over and over and over and over again, changing the parameters. Well, that makes a really, really big hunk of data that you can try to start figuring out interesting things about. My particular model was to figure out what part on the outside of your torso would tell you most about the inside, you know, near your heart. That was really cool. But for me, what made it difficult was I would work hard all day. I would run into stuff and think, well, that didn't work, and I would toss it and start again. That taught me that I really needed to be the kind that built something and looked at it at the end of the day and thought, awesome, I built something, I did something, and I accomplished something. Research, you do accomplish stuff, but you're going to run into dead ends. You are going to run into stuff that doesn't work. I learned that I liked building rather than exploring. That's me. Other folks that enjoy exploring will do just fine and love it to death. But that's what told me that I wasn't cut out for research. That was a personal thing. Yeah?
Do you recommend learning abroad?
I would have liked to, but I've never met anybody that actually has. In you know, that'd be cool though.
Learning what?
Learning abroad.
Abroad.
That would be cool. I'd enjoy it. But I haven't met anybody that in the 2 companies, you know, that really small sample set that I've been with, I haven't met anybody that's done it yet. I can't even remember what I got next. All right, just a little thing. You're not going to stop learning when you get out of here, right? You're going to get to your first job and they're going to ask you to do stuff that's slightly or maybe way beyond what you currently know how to do. How many of you like Stack Overflow? I use it every day still. You will always use it. You will always be looking around to know whether or not somebody's done something first. You'll be always learning new stuff. You know, just this past week we had one of our guys have to, you know, this guy is one of the fellows that helped like write Rails, you know, Ruby on Rails. This is a crazy, crazy good guy. He's out in Hungary and it's like, hey, we need to do a Google login, you know, log in with Google, do the OAuth stuff. He looks up the guides too. You know, you will look stuff up and you will keep learning. But learning is one of those things that's going to help you, you know, stay satisfied with where you're at, with where you're working. It also gives you new bags of tricks. The app that I'm working on, it's a web app. It's about 6 years old. Can you guess how many flavors of JavaScript are in there?
20?
Just about, yeah. It's something that you've got to keep up on your toolbox. You know, my first job was working in Visual Basic SSRS reports. Visual Basic is mostly dead. That's not good. You know, when we did go through layoffs at our job there, when, you know, the oil crashed a few years ago, if you noticed. Working for an oil company, that wasn't the best place to be. But if you happen to know more than Visual Basic, you stood a much better chance of surviving. Being able to do more than one job, that increases your odds of surviving. That does mean that you may not be an expert in one field, and so you've got to think about that. I like being a generalist. I like knowing a little bit of everything. At my job right now, I do iOS, I do Android, I do web dev, I do front end. I do a little bit of everything. Now, that means I'm not a master at anything. We've got our guy in Hungary who can code rings around me. He can do all sorts of stuff that I never even dreamed of. He's got 20 years of experience. He's fantastic. But I can do features. I can test. I can read code. I can do code reviews. And I can code in React just fine. So there's a lot to be said to be able to move over to other projects. And in a startup where I'm at, that's really handy. If you go to a startup, you're going to be doing more than one thing. You can't specialize in a startup. You're going to be doing more than C++, more than just backend. They can't afford to hire a bunch of people, so you may need to do a lot. Let's talk about that as soon as we get past the where you want to work. What do you want to work on? Asked you if you wanted to be game designers. How many of you would have loved to be the guy that did Candy Crush? I would love to be that rich. Could you go home at the end of the day being satisfied? Say, I entertained people today, and I feel good. I addicted millions of children to my wonderful app. I feel good. Beyond that, writing a successful app and knowing that you entertain people, is that enough to keep you happy? You got to think about that. If you wrote a really cool game, you made something look good, is that enough for you? Or do you want to be, so that's one of the cleaning pigs that I got to help work on. That's a little R2-D2 that goes through an oil pipeline. We'll read and listen to the pipe, push calipers out on it, see where Farmer Dan hit it with a backhoe. It finds things that go boom before they go boom. You could go home at the end of the day and say, hey, I stopped somebody from blowing up. That's pretty cool. And that happened. We would say, hey, you should go dig this up. Somebody is going to die. And they would dig it up and they would show us the pipe and they would show this big old rusting thing that was about to become a hole. That was cool to me. That was a scientific application that I felt pretty awesome about. You can be crunching numbers. You've got business apps that do, task management, retail work. You can do, useful things in automation. Saving people time. Is that good for you? Do you feel happy about that? You need to think about that when you're looking for your jobs. If you don't like it, it's going to wear on you. You'll know about it when you talk about it. If you are, all right, we went through that. If you think your job is cool, you're probably going to be happy and do a better job at it. If you're proud of what you do, ditto. You're gonna like it. You're going to do better work. If it's just a job, if you're thinking maybe it goes belly up in a few years and you don't care, if you're disengaged, you just if you think about what that does to your quality, there's something there beyond just getting paid. And I know that's intangible. I know that's hard to think about right now. Think about your homework right now. Getting it done, doing a good job, enjoying it makes it faster. There is a shadow there that you're going to see when you work in the real world. You're either going to like it and do good quality work, or you're not going to like it, and you can tell that it's not your best. How long could you last in a job you hate? Year? 2? I'm going to guess not very long. I'm going to guess that it's going to just, if you don't like it, you're not going to survive there. You're not going to like it, you're going to leave. Now, there's an interesting thing that Peter said in the last time we did this. He talked about the golden handcuffs. The idea of having to break out of something that's nice for something that's better, right? You're going to have to start thinking, do I have enough bad days at this job that I should go and look for a new one? You're going to have to think, do I want to get paid more? Do I get paid more for switching jobs? Is that worth looking around? And my experience about pay raises is consistent with most other folks I know in that switching jobs generally does give you a pay boost. Now, being somebody that interviews folks, seeing people jump all over the place puts up some red flags in your head too. So, buyer beware there. You can jump around all you want, but you've got a professional reputation too. You've got to see projects through. You've got to do good work. I think that if you have more bad days than good days for an extended period of time, you might be thinking that it's time to leave. You're going to have to figure that out. And there's more you can do than just up and leave. You can talk to bosses. You can talk to people and ask, hey, how can we make this better? There's a lot to think of there. All right. Any other questions before we go on to, yeah?
When you're like interviewing people or looking at their resume, is there like an amount of time they stayed at a job that's concerning for you, or a number of times they switched in a time period?
If they were there for less than a year, I'd probably ask. If they were there like 6 months or less, that's me. I mean, take that with what you can. But if somebody's been there less than a year, I wonder, why that didn't fly. People move, people change. There are legitimate reasons for switching in less than a year, totally. But when I interview, I ask, all right, you were only here for 3 months. Tell me about a conflict you had and how you resolved that. Anybody else? Any other questions on that? Yeah.
This is jump back to something you said earlier, but did you compete with programming?
I didn't. I wish I had. That was a cool class, and so I don't know if Peter or people will have you do that, but there are code competing sites that just do normal problems. Hey, do a linked list, or hey, solve this problem in like 5 minutes. Those were really handy for me for a couple of reasons. Yeah, you're not going to write the best code in 5 minutes ever, right? You're going to be coding to do the problem. But there's something to be gained in learning to think quickly, to find out ways to solve a problem, to know your language well enough that you can... There's a lot of experience there. I mean, if you ever wonder why you get such long, big assignments here, it's because they want you to spend time in front of a computer, right? And doing those sort of coding competitions really make you problem solve. Anybody in this world can type now, right? Just about everybody can do more than Hut and Peck. So your big asset isn't your typing capabilities. Your big assets are your ability to solve problems, your ability to architect solutions, your ability to learn new solutions. I mean, the fact that you're here means that you all ignored the siren call of Dev Mountain, right? You all know what Dev Mountain is, right? All right, Dev Mountain, 12 weeks and you'll be a coder. Sounds pretty good, right? They're not going to know everything you know about how to solve problems, what's going on in a computer. You wonder why you're actually working and knowing what's inside a computer. I mean, when I was here, we actually had to know, what a no-op was, what the actual ASCII things were. We did assembly code. I don't use assembly code. But you learned about what's inside, you learned about the architecture, you learned good programming. And that's, you always want to get paid for what you know more than what you can do. Knowing how to really make stuff is worth way more than a 12-week course will ever do for you. Okay. You want to talk about startups and big companies? You want to talk pay stuff? What do you want to know?
Startups.
Startups. Okay. You're next. So, let's start smaller business. Startups. It's exciting, right? And the good news is you're going to be a rock star to them. They think you're magic. They will say, hey, I want you to make this website, and you do it, and then they clap for you. I'm serious. You go to team meeting, and they say, look what they did. Woo! And they will clap, and they will love you, and you will go, that feels great. You do have the possibility of going big. Okay, now, this is like the lottery. Your odds of winning go up when you purchase a ticket, right? You could go big. That's a possibility. Not many do, but if you go working for somebody else at a big company, your odds of going big are not there, right? So there's a possibility. Nice thing about a small company is you know everyone, right? I mean, there are 8 of us. We know everyone. That's a pretty cool thing to actually know everybody that well. You know, we went and did a trade show in New York, and we went and bonded as a team, and we know each other. Like, that's, I won't say family, but it's more than your general work relationship. You care about each other. You know whose kid's sick. You know who's moving. You know who's doing what. That's worth something. That's a little more than you would get, you know, being a cog in a big wheel. There's absolutely no red tape at all. Somebody thinks of something, and the next thing you know, you're working on it. That is nice if you hate red tape. You've got the freedom to swing. I mean, you say, hey, I think this needs to be done, and you can go and do it. You can say, I want to do this feature, and you can do it. That's pretty cool to have that freedom. You get to do a lot of the deciding. That's nice. You can pump up your resume. Right now, by virtue of being one of the last people standing after a furlough and running out of funding money, I am the technical lead, right? I get to be the acting CTO sort of guy because everybody else left when we ran out of money. Now, a little side note there. I did not work for free when they ran out of money. I went and did a contracting gig that I left open for my last job. What kind of favors to prepare there? So don't burn bridges. Don't burn bridges. The way this happened was I was at my old company. Startup made me an offer. I left things nice enough with the old company that I still contracted with them on a weekly basis. Like 5 to 10 hours, nothing big. But when the startup went down, I could just spin up and start full-time at the old job. And they paid me more as a contractor. I didn't get that. But, so, as a side thing, you know, if you can cover your bases, that's a nice thing about, you know, a startup. You can pump up the resume. Yeah?
Did you negotiate for equity? And if so, do you have any recommendations?
So, I did not negotiate for equity when I got there because they were paying me pretty well. You know, they knew that it was a risk for me to leave, and they compensated me accordingly. They also couldn't do a benefits package because they're a startup, so they gave me a stipend for benefits, which was really nice. Considering my wife works and we got our benefits through her, I got to pocket it. That was cool. I thought that was fantastic. I wasn't getting paid for those benefits at my old job. But during the furlough, they did say, hey, we need this to happen. We can't pay you. We'll give you a little bit of equity. I don't like working for free. It feels bad. It's not good. I would not recommend that to anybody. So we wrote out how many hours for what percentage of equity, and I've got that. And that was mine during the furlough. They needed work. I had a little bit of spare time, and so I could leverage that, you know, that need to get a little bit of equity. It's not huge, okay, but that is something that you can do. And if you're working somewhere, and if you're working at a startup, a lot of the times it's seen as your retirement package, right? It's not a good retirement package, but that can be I mean, you're taking a risk, aren't you? Working for a startup? Yes, you are. No 401k. That's not good. No health benefits? Even worse. So you should be able to know that's a risk and get compensated for it. You can negotiate equity. I like money, but that's because I am not a team player, so to speak. I'd rather have the money than the equity. Let's talk about some downsides. So, you're at a startup. You produce or you perish. Literally. If If you don't succeed, it's over. There is no bigger business to fall back on, right? It's you. If you are the lead developer, it's you. Nobody's going to save your butt. It's you. You've got to do whatever needs doing, which means me, who hates front-end work. I hate it. I do that all the time because it's got to get done. There's nobody around to do it. You do a little bit of everything because you have to. Fewer benefits, there's a lot less recovery altitude. Things change quickly. You can have money one day and then your funder can say, I'm done. They can do that. One day you've got funding, one day you don't. So to be able to take those risks, you need to be able to make sure you can. I mean, if you got a family, it probably means you need some savings or something before you jump full on at a startup. If you've got a safety cushion, you can take risks. I would not have gone to the startup if I didn't have my contracting job to save me if things went really, really badly. That's what made me feel comfortable. You're going to have to figure that out on your ends. Let's talk about big places. So, big places like Amazon, Microsoft, anywhere over 2,000, I call big. And there are a lot of those. You've got some stability, right? They're not going to disappear overnight. Maybe a more relaxed atmosphere, depends where you're at. I mean, you think of hardcore places like Goldman Sachs or whatever that are known soul eaters that work you really hard. Maybe not so much, but hey, they pay you well. And you do your work and you go home. That's nice, right? You're not always on the clock. My first job, it was 9 to 5 or 7 to 3, because I liked that better. And then you went home. That was it. You closed your computer, you left your computer, and that was it. That was nice. A deeper talent pool means that you've got help. I came out of the U and poof. Hey look, that guy's been coding longer than I've been alive. I can learn. I can pick something up from them. That's really cool. You're going to learn more. You're going to figure out stuff a lot faster. You've got code reviews. People are going to look at your code and say, that's not right, and that's good. I mean, code reviews are the best thing that happened to me there, because I could put up my code and I accidentally posted my first review to the entire dev team. I got eaten alive. It was like my first real industry C++ code. I got nailed on so many stuff, but I didn't do it again. So that was handy. Code reviews are helpful. Where I work right now, we force a code review on everything that goes into the repository. Somebody has to look at it and say, that's okay, before it goes in. You don't get to check in before somebody says it's okay, and you have to increase test coverage. That's a must. You have to increase test coverage or it doesn't go in. Those are really nice safety nets that you can do for yourself, big or small company. But let's see, predictable work. You know what you're going to do in the morning, and you know what you're going to do the next day. That's nice. Good benefits, 401ks, health benefits. Health insurance is expensive. That's nice. And what do you know? There's a ladder to climb. You can actually go and ask your HR folks, what do I have to do to be a level 2 engineer? And they might give you a rubric and say, you have to do this, this, and this, and this, and this. And then you can go up to them and say, hey, I've done this. And they'll promote you, and life is good. If you like that structure, that's good. That can help you know what you need to do to improve. There's a lot of people to help you out. Bad stuff. I got bored. I got bored really easily. When I was doing SQL reports, that was boring, right? It was, we went from MySQL to Firebird. Don't ask me why, that's a long story. But that meant we had to convert 1,000 reports, 1,000 SQL reports. That was a big honking project, but I knew what I was going to do every day. But I got a little bored, right? You can get bored. That's not good. You can get pigeonholed if you happen to specialize in something and you're good at it and you do it and you don't want to stop. You might get stuck. That's a company by company thing. That happened to me. I had to work hard to break out of that. Less recognition. You're not going to get applause at your team meetings. You might. Not so often. you might have to jump through some corporate hoops. Stupid stuff that you don't think makes sense, but you got to do it. I took so many trainings about exporting like oil across borders that I didn't need to know how to do, but I had to do. It was part of the thing. I wrote an extra website for, somebody in our building said, hey, I need a website. I said, I want to learn how to do that. I'll do that. I got my hand slapped by IT because that wasn't in our department. They took it away. They went, phew. That felt bad. That was red tapedom that I didn't like. Not all red tape's bad, but you get the idea. You might run into that. And you might have to, do a little bit of competition. You want a promotion, other people are going for it. You might have to deal with that. You might deal with that everywhere, but I didn't like that sort of thing. All right, you had a question. Well,
You've answered that already.
yes. Okay. What other questions do you want to know? I mean, and we're getting close to that 40-minute mark. Yeah.
So this is more of a general question, but if you were to drop everything and go to a different company, how would you show them your experience? Especially if basically we're working as and want you to show your code.
Well, if I want to show my experience, I'm going to have to talk about it. I mean, I have not gone through a lot of technical interviews. I mean, I got my internship, got a job, then did another. But you're going to want to be able to talk about it. I mean, in an interview setting, you're not going to be able to pull up your GitHub and show all of your goodness. That'd be cool. But I've seen people put their Stack Overflow ratings on resumes too. That does tell you something. But to show your experience, being concise on what's on your resume, saying this is what I did, and then when you go in there, you talk about it. You say this is what I did, and this is why it's cool, and this is why I did a good job. Most interviews that I've seen or done, they're not so much as, hey, do a bubble sort or do a merge sort. Tell me what's wrong with this code. It's you sit down and you talk about your experience. And that's happened to me more often than the technical, tell me what's wrong with this code interview. But you're just going to have to talk about what you've done. What other questions?
You ask questions.
Nobody's asked salary or anything? Yeah.
That was going to be my question. How big of steps have you gone? What was your internship pay, and then what are you getting paid now?
Okay, let's talk about that. I started interning at $17 an hour, which I thought was pretty cool. I mean, that felt good. And when I got hired full-time at the oil company, I ended up starting at $64K. I was fresh out, got there $64K, which I thought was pretty fantastic, which is about par for the course from what I've heard from other folks. You can get a little bit more, a little bit less, but that seemed to be par for the course. After about 2.5 years at the oil company, I applied to be a software engineer level 2. So I've gone through their rubric. I mean, in general, people would expect a little more experience before you move up to level 2. But we had gone through a bunch of firings. I'd been doing a lot of other people's jobs. I felt like I could argue the case. After I did that, I went from about 64 to 75. Level 2 took me up to 75, which was really, really nice. And I thought that was fantastic. I thought that was good. Now that I'm at the startup, I'm on camera. I shouldn't say my complete salary there, but with all of my benefits, stipends, all that, I jumped from 75 to between 90 and 100. So that was pretty fantastic. If you include the benefits, include all of that stuff that they're just flat out paying me, I jumped from 75 to 90-ish to 100, in that realm, which was amazing to me. I thought that still is amazing to me. But they're a startup. They've got to understand that they're paying for your risk. So I feel slightly overpaid, but when I remember the risk that I'm taking, I feel better about it. Is that weird to think? But
Why don't we stop there? If you have any other questions during the break,
yeah, come and see me.
Thank you.
Thank you guys.
When you're ready. Go. All right, let's get started again. Andrew wanted me to remind you, he put a poll up on Piazza trying to find out people's preferences for when to have the review on Wednesday. So on Wednesday, he's going to be having a session going over the solution to the sample final that's online right now. So help him out with that. We do plan to live stream it, so if you can't make it, you can do it online. Okay? So first thing I'm going to do is talk a little bit about a partial solution to the orthogonal service. Before I start that, are there any questions you have not related to that? Assume that's your main point of focus right now. Okay, so let me just show you what I did. Oh, by the way, I don't plan to put this online, so it'll certainly be, it'll be online in a sense, since it'll be in the video. But I'm not going to post the code itself, so you just need to pay attention and ask questions. So I did what I asked you to do. I created a project that was structured like it said in the assignment, and then I started to work on the service. And I just want to show you how you can take advantage of string sockets, because I've gotten a lot of questions about just receiving the first request. So here's my main method. I create a string socket listener to listen on port 60,000 using UTF-8 as the encoder. That is entirely analogous to how you would use a TCP listener if you were going to use regular sockets. So that's the server. I start the server, and then I call the begin accept string socket method on it, and I give it a callback to call. So basically, when a socket request is made, it'll create a string socket and call connection made with that string socket we created. Now, here's the method connection made. It is told here is a string socket. And what we have to do with that string socket is read the lines from it, which is going to be an HTTP request, deal with the request, and then write a response to it, which again would be writing out lines of text. So we don't have to deal with bytes. So what I do is I tell the server to begin accepting string socket requests. I basically put the line here that I had up here, and this is not going to work. I need to change that and test this much. So if I were to forget to do this, I would receive no more requests. We've talked about that before. And then I create a request handler object, which we'll look at later to deal with the string socket. So this is the plumbing. As requests come in, we create request handler objects to deal with the request. So every request is dealt with by a different request handler object. And so this is just called over and over again. Every time there's a request comes in, connection made is called. All right? Any questions about that there? Yeah?
So when I tried to set it up on port 60,000, I was running into issues saying with the firewall, but if I switch over to port 4,000, it works fine. Is that all right to do all of the work in port 4? Are basically all the ports treated the same? So when at the end, if all of my code works, can I just change it to?
Yeah.
All right, cool.
Yeah, that should work. Okay? So there's an aspect to this that no one's asked about and that I didn't mention. I'm actually making use of the payload here. So I have my choice. I could have created a static variable to hold the server. The server is declared locally. Down here, I've got to have the server so I can call begin accept socket on again. And I decided just for variety, instead of declaring a separate variable, I pass the server as the payload. Okay? So what I'm saying is when a string socket is created, pass that string socket connection made, but also pass this as the payload. And then you can see as soon as I get into connection made, I take the payload object, which I know is a string socket listener. I cast it. Then I've got it. Then I can use it, passing it through again as the payload. So the payload, that's, I've never really shown you an example where the payload is useful. The payload is used to pass, if you need to pass information from one spot to the other, you can do that. So anyway, this just spins up, for every socket request that comes in, we get a request handler running to handle it. So let me see what other questions are. Yeah?
Why not use a closure instead?
Use what?
A closure instead of a payload. So you define the function in the main function, then you can capture the server variable.
And we can make that work. Let's see. So down here, what's going to be passed to connection made?
Well, no, you define the function of take string socket.
Oh, okay.
Yeah.
So define connection made to take a string socket and capture. Yeah. Okay. So there are other ways to do it. Yeah, I just wanted to illustrate the use for a payload, a use case for the payload. Right. A number of ways to do it. Any other questions? Yeah.
We're doing like the server.start. Does it matter? We never call .end. We just like close the program.
Yeah, I didn't think to call server.end.
Okay.
Because actually, the way I've written it here, it just doesn't end. Right? I mean, it doesn't end until I kill the program. Yeah?
On my server, I thought that I had all that it was completely implemented and working, but now when I run it, and I'm not sure what change might have done this, when I call string socket listener.start, I get a socket exception, and it says that an attempt was made to access a socket in a way forbidden by its access permission needs. Do you know why that might be happening? Do you know?
I'd have to look at what you're doing. One thing you could try is try it on a different port. Maybe the port's in use. Yeah, I'd be happy to look at it, but I can't really debug it. Stand it. Any other questions? Yeah.
I am kind of confused on why the string socket list is even being used in the first place. In our implementation, well, in my code, the string socket is the only thing I'm using. I've been able to receive multiple requests over time doing that.
Where do the string sockets come from?
The SS listener, or that I'm calling, but I don't keep a record of the. Maybe I'll just have to show you my
Okay.
implementation.
I mean, you've got to use some sort of, string socket listener, TCP listener, something
We're doing that, yeah.
to receive the requests,
Yeah.
right? And then you get a socket request and you deal with the socket, right? Okay. So what am I doing differently?
I suppose it was just you're getting the string socket right there. It's called SS.
Right.
You have it. Isn't that the only thing you need?
Yeah.
So then why are we using the payload at all to make it a server?
Well, I need access to the server variable. Right?
So I'm not doing that.
Well, like I was saying, you could declare this variable as a static variable
Okay.
and access it that way. Maybe it was a mistake. I just wanted
I see.
I just wanted to show that the payload can be useful.
Okay, cool.
If no one does it this way, that's fine. I just wanted to do it.
That
Okay.
makes sense.
Why the code going on? Any other questions? I mean, the interesting part where we actually deal with the requests down below. Okay, so for every string socket, we call that constructor. Now let's see what that constructor does. So there's a class, obviously. There's a request handler. And it has some instance variables. The string socket that's being worked on. The first line that was read from the string socket, which is crucially important because that determines what service is being requested. So I save that. The value of the content link header, if there is one. And a couple of regexes that are used. So here's the constructor. It just records the string socket. It sets content link to 0, and it calls begin receive. So it calls begin receive on the string socket and says when you've got when you get a line when you received a complete line, call read lines. So that's the constructor starts things up by calling that. So at some time in the future, read lines is called. Now, read lines is used as a callback. So you notice in here we're calling begin receive again using read lines. So this is my only method that deals with lines of text. And it's essentially a simple state machine. So very first thing is it looks at the line. If its length is 0 after trimming, that means that's the blank line that marks the end of the request and the beginning, possibly, of the encoded JSON object. So we only reach that point after we've read and processed a bunch of lines to read lines. So at some point you will see the blank line, and if you've previously seen a content length that's greater than 0, that means you need to read some bytes from the end of the request and turn it into a JSON object. So what we do is we call begin receive here. We say read that many bytes please, and when you've got them, we call process request, which is the next method there. So that's what ends things. Now, if the length of the line is 0 and there was no content length header, then we just call process request directly with null, which just means there is no object at the end of the request. Okay? Otherwise, if our first line is null, if our first line variable is null, it means that this line we just received is the very first line of the request. And so we have to, oh, I'm sorry. If first line is not equal to null, that means this isn't the first line. And at that point, we're not at the first line and we're not at the end. We're somewhere in the middle. Only thing we have to do is see if we got a content link header. Otherwise, we just throw the thing away. Everything between the first line and the blank line, we can ignore except for the content link header. So I take that line, I match it. I have a pattern that matches the content link header. And if it matches, I parse out the actual value of the integer that's in there and save it in content length, and then I begin receiving more lines. I call begin receive again and say call read lines again. Yeah?
I haven't seen match before. Is that just like a true-false kind of thing?
Well, I run match against the pattern, and this contains information about the match. Okay? M.success is the match, a match occurred, that it was a content link header. And M.groups pulls out the actual integer that was in the match. Yeah?
Does match belong to the regular expression namespace? Or
does match do what?
it belongs to the regular expression, right?
Yeah, it's a method of it. That's a regular expression there.
Okay.
So up here, if we look at the pattern, content link pattern, it says a content link will be at the beginning of the line. It'll say content link colon space followed by one or more digits. And I say lowercase because case doesn't matter. When the match succeeds, this thing in parentheses is going to be the first group. It'll actually be the actual integer. So I can match it and match the integer all at the same time. So that down here, M.groups1 will be that string that was matched. That's the digits. I convert it, I convert it to a string and parse it as an int. And that's our content link. Otherwise, if none of the above apply, we must be looking at the first line, and so I save it. I just save the first line for later use, and you can't forget to do begin receive, so you get the next line. So as each line comes in, this method is called. It figures out what state it's in. Is it looking for the first line? Is it looking for content link? Is it looking for the last line? And responds accordingly. Yeah?
Why groups 1 and not groups 0?
Groups 0 is the entire string that was matched.
Oh, okay.
Group 0 is the first captured group. I'm sorry, group 1 is the first captured group. There's only one captured group. Okay? Yeah?
How do you handle a case where maybe you don't get the content length or one of your regexes doesn't match with both the lines incoming?
Well, if there's no content link, this match will never happen. And we'll just go through all the headers and eventually get to the blank line. If we get to the blank line and we've never seen a content link, then we're falling into the case where we just directly call process request with null, indicating that we're not looking for any bytes after the blank line. Now, there could be cases, I'm not really checking here for malformed requests. Now, a more robust implementation would, if it's, a strict implementation, we're checking all the headers and making sure that they're all formatted just so, but we're not bothering with that. Okay? So this is how I chose to adapt the way the nature of begin receive with the callback. I started by writing a method that would deal with the first line, and then it would call begin receive and give a different method to deal with the headers, and then a different method to deal with the blank line, and a different method. That seems stupid. So I just always, the callbacks always call back to read lines, and it just looks at the state variables to decide what it's supposed to be doing right now. What's it looking for? Okay. Now eventually, we either decide there's an object coming, and so we read the specified number of bytes and pass that string to process request, or we call process request with null. And so process request is the last stop. It has a line of text if there's an object at the end, or null if it doesn't. We're not using the payload. So I have a regular expression to match against the first line. And the only one I have is called make user pattern. So if the first line is in the right form, we do this. I've only implemented that. So if you follow this pattern, you would have else if a different pattern matches the first line, do the right thing for it, and so on. So let's look at that pattern. Here is make user pattern. So if the first line at the very beginning, if it says post, followed by a space, followed by this URL, followed by a space, followed by HTTP, and I guess I could have put /1.1, but that was enough of a pattern for me. Then we know that we're supposed to create a user. Okay? So you can always tell what service method you're supposed to be doing by that pattern. What if there are parameters embedded in the URL you're supposed to extract? How would you extract them? Yeah? Groups. Yeah, you'd use matching groups just like we did here. You would put matching group information into your pattern. So anyway.
I'm back. Your overhead's not.
No.
I'm back.
All right, hold on a second. How can this be?
There it is.
So you're gone now. Okay. So when you watch this video now, the screenshot's missing.
What did you do?
I just disconnected it because I have to make progress. So you just have to look at it on the screen. Sorry about that. This is my process request method. So it knows that it's just seen a pattern that matches the first line. So what do? Well, I take that line and I deserialize it as a name object. Okay, the line parameter is the last chunk of bytes that is the coded object, the serialized object. So I deserialize it. You want to make sure that you specify the name, not the name, the type of object you're expecting to get. So we do deserialize it that way, we get a name object. That's just in my, I have a models class that was left over from the last version of the server. And a name object contains a nickname in it, right? That's just what comes along. So we deserialize it. I create a new boggle service as my class that contains my service method. So I create a boggle service object and invoke make user on it. I pass it the name object and an out parameter, which is the status code. So there I'm actually running the method and it's manipulating the database or whatever. I get the answer back. what I should get back from bubbles from make user is a user object that I'm supposed to send back to the user. So I need to make a response. So first line is HTTP 1.1 plus, then I put the status in int form, like 201, and then I put the status in string form, which is just going to be created. So the first line will be HTTP 1.1 space 201 space status, assuming we got a 201 back. Just, it does whatever it does. If it was a 200 status code of some kind, I may have gotten back like an error, like some sort of error code. But if it was a success code, I have to take the object that I got back and with the user object from right here, serialize it into a string. I have to output content length, which is the number of bytes it took to represent that string. And then I have to stick the result on the end. I have to put that this thing, the serialized object, at the end of the HTTP response. So what I have is first line, content length, serialized object. Or if it wasn't a 200, all I've got is that first line. So whatever I've done, I just send out my string socket. So, yeah?
Do you need a blank line between content length and the object?
No blank lines in the response, just in the request. Yeah?
I noticed that when you were using your regular expressions to search the HTTP requests, you had long and specific regular expressions, which probably will be do a good job at preventing URL issues and such. But my implementation that has been up and running right now, I just used really simple words like post or users, and I didn't worry about all the punctuation or the URL and stuff. And it's working.
Yeah.
I suppose if you had a socket connection with this server, but you attempted to do a call to a different server web page name, it would still work. Would that be fine? Is that an issue?
No, a real server would be checking the HTTP, making sure the protocol is just so. But you don't have to do that. It's whatever works. This isn't a real server. Yeah.
Sorry, just to make sure I understand the structure. So at the end of it, you're shutting down the socket as soon as the send is done. But every time a new request comes in, the user has to create a new string socket.
Yeah. Every request, a string socket is created. We use it, we shut it down. That's how the protocol works. There is an option in the protocol to try to keep the socket alive for the next request, but it's not required. We're not doing that. Yeah?
In my project or solution, I have like the PS10 version of the server in addition to the PS12 version. Like in that, do I need to delete the PS10 version before turning it in?
You don't have to delete your. It might help avoid confusion. I think that's okay. Someone reported that the presence of their PS10 solution was causing their PS12 solution to not work because it was somehow running and using the socket.
Yeah, like unloaded.
Someone else said that when they sent back an error code from their server, that the advanced REST client wasn't recognizing it as a valid response. I had the same problem until I put the shutdown here. That's just saying after the string has been sent, shut down the socket. And that made the advanced REST client happy. It was waiting to see the end of it was waiting to see the socket be closed. Okay? Any other questions? Yeah?
Will your main method in the server class clash with the main method in the program class?
Say that again.
Your main method in your server class, will that clash with the one that's in the program?
Repeat. There's only one main method. He's asking about main methods clashing, but I don't see the second main method's coming
So
from.
you know how there's usually like a program file in the solution?
Yeah, this is my program file.
Okay, so you just don't use the...
Yeah, you got to have, in your project, you just need one main method. You don't want to have two. But different projects can have their own main methods. So if you were to take this start, what would you have to do to expand it into a solution? Yeah.
I would think that what I did is I put the try catch around most of that block there, and if anything went wrong, I would return
Okay.
400 forbidden. Is that a good way to handle it?
Well, I would say if anything went wrong, it should either be a 400 or a 500 code, depending on what went wrong. But we're not going to quibble about that. But besides making it more robust, yeah.
You need to handle all the other requests.
Right. You need a block like this for every request, that's all. So I've shown you how I did make user. So there's another one where you say, join a game. Request status. So if you're working in the same way, you create a regular expression that matches each first line that you expect to see. Use that to control which block of code you execute. And then the different blocks, what you do depends on what needs to be done. Do you need to extract information from the URL? Do you need to deserialize an object or not? What do you send back? You're sending back an object or not? So it's just a matter of replicating that. And if you're going to go this route, I would start with this, make sure it works in the advanced REST client, and then add the next type of request that comes in the protocol, the join game. Make sure that works and move through it that way. Doesn't have to be hard, especially now. So, any other questions? Yeah.
We started in the same solution from PS10 or PS9, depending on what we pick. And we created a new project. After we have it up and running, do we need to keep the old project and its tests and stuff, or can we just...
You can get rid of it if you wish. Anything else? Okay. Now, I've got 5 minutes worth of stuff to talk about. So I'm going to do that. Okay, so we're talking about copyrights, and we were talking about sort of famous copyright cases. Someone asked me after class about this case, so it seems appropriate to talk about now. So Sun Microsystems developed Java in the 90s. And Sun was acquired by Oracle, so now Java belongs to Oracle. Google, at some point, adopted Java. So on its Android platform, you program it in Java. So if you're using Android, you're using a Java implementation, you're using the Java API. They've added their own APIs, but you've got Java here. Now, rather than license Java from Sun or Oracle, what Google did was create what's called a clean room implementation of Java and its libraries. Okay? So you're free to use a Java compiler to create programs. That's not a problem. That's not a copyright problem or a patent problem. But if you want to, basically Google is selling Java as a product on the Android platform. Right? They're providing it there. So they didn't want to, instead of paying a licensing fee, they just said, okay, we'll just take the Java language and its API and re-implement it all. And clean room just means they did it without looking at the source code. They just implemented it from scratch. They were sued in 2010 for a couple of things, but what we're interested in is they were sued for violating, infringing Oracle's copyright on the API. Not on the code that implements the API, on the API itself. So that you look at the API, you see a hierarchical collection of information. It's organized in a certain way, the classes are named, the packages are named, there's a documentation, there's all that. That's the copyright that Oracle claimed was being infringed. Not the coding, which Google had reproduced. It was the actual API that people look at, the documentation, the organization people look at when they code. So they were sued. You can look at the Wikipedia page, and there's just all kinds of, there was jury trials, there were judges that gave decisions, there were appeals. It's bounced back and forth. It was in the news recently because an appeals judge the court had decided that Google was making fair use of the API. We talked about fair use last time. It was appealed and the judge said, no, that's not covered by fair use. And they sent it back to the trial court to decide damages. So that's where it sits right now. So a lower court's going to decide on damages. Oracle wants $8.8 billion in damages from Google. People are concerned because there are other examples out there of APIs that exist and have been re-implemented, repurposed. And there's a fear that if this decision stands, it will have a chilling effect on sort of the free use of APIs. Imagine what that would be like. And so it's just, I say it's likely. I'm certain this will be appealed by Google before they're not just going to cough up $8.8 billion. Yeah. Although they have.
Just so I understand what Google did, so they essentially took a Java doc, for example, to explain what a particular class did, or rewrote the class according to what Java doc said.
Right, right. And they're not being sued for having re-implemented.
Because they wrote the own code.
It's their own code. They're being sued for continuing to use the actual Java doc. And the way, and in the same organization of the library. They're not being sued for reusing the Java language. That was okay. It's the way it is protected. The copyright on it allows people to re-implement Java, the language itself. But it's reusing the API itself, the API specification. Yeah.
Isn't the purpose of API specifications and that sort of documentation exactly so it could be reused?
Well, it's so that it's a standard way for people to use the API. And that's fine. It's just what Oracle claims Google is doing is they're taking the API and they're basically they're making money off of not using. They're not making money off people using Oracle's version of the API. It's Google's version. They're basically selling the API, if you will. That's the claim anyway. So anyway, this is a crucial case, and who knows what it'll turn out. I wouldn't be surprised if the Supreme Court ends up arguing about it. But anyway, stay tuned. So we'll wrap up intellectual property next time and then do a review.